In this video, we are going to talk about two other rules in exponents. One is called the zero rule, and the other one is the negative exponent. Now, this means that any base raised to an exponent of 0 is equal to 1. So this means that x exponent 0 is equal to be 1, no matter what the value of x is. For instance, 6 exponent 0 is equal to 1. This is the zero rule. The next rule says that any base x raised to an exponent which is negative is the same as, for instance, x exponent negative a is the same as reciprocal, meaning 1 over x, but this time to the positive exponent a. And this is true. X exponent a is the same as 1 over x exponent negative a. So this is the rule which is very important of negative exponent. So the rule is x exponent negative a is 1 over x exponent a, or 1 over x exponent negative a is x exponent a. For example, 7 exponent negative 2 is the same as 1 over 7 exponent 2, and 7 exponent 2 we know is 49, so it's 1 over 49. Or 1 over 2 exponent negative 3 is the same as 2 exponent 3, and 2 exponent 3 is equal to 8. The first example says evaluate 8 exponent negative 2. So I can write 8 exponent negative 2 is the same as 1 over 8 exponent 2, which is 1 over 64. The next one says 7 exponent 0. Remember, any base exponent 0 is going to give you 1. The next example says negative 4 exponent negative 1. I can write this one as negative 4 exponent negative 1 is the same as 1 over negative 4 exponent 1. We know that any number exponent 1 is the same number. So this is the same as 1 over negative 4. The next example is 3 exponent negative 2. So I can write 3 exponent negative 2 is the same as 1 over 3 exponent 2, which is 1 over 9. The next example says use the exponent rules to evaluate. I can write this multiplication as 4 exponent addition of exponents. So it's 3 plus negative 5. 3 plus negative 5 is going to give me negative 2. Now 4 exponent negative 2 is the same as 1 over 4 exponent 2. But 4 exponent 2 is 16. So it's 1 over 16. The next example, we have to simplify negative 2 exponent 2 divided by negative 2 exponent negative 5. Since we are dividing two powers with the same base, I'm going to subtract the exponents. So I'm going to get negative 2 exponent 2 minus 5. But minus 5 is positive, so it's going to be 2 exponent, negative 2 exponent 2 plus 5, which is negative 2 exponent 7. Now, using your calculator, negative 2 exponent 7 is negative 128. Always remember, the base, if the base is positive, to any exponent is going to give you a positive number. If the base is negative, then if the exponent is an even number, you get a positive result. If the base is negative and the exponent, like this case, is odd number, you always get a negative result. The next example is to simplify 4 exponent 2 divided by 4 exponent 5 exponent 2. So again, I use power to power and I distribute the exponent 2 inside the bracket. So I get 4 exponent 2 divided by 4 exponent 5 exponent 2. Now 4 exponent 2 is 4 exponent 2 times 2. 4 exponent 5 exponent 2 is 4 exponent 5 times 2. 2 times 2 is 4, so I get 4 exponent 4 divided by 4 exponent 5 times 2 is 10. So I get 4 exponent 4 minus 10, which is 4 exponent negative 6. Now 4 exponent negative 6 is the same as 1 over 4 exponent 6, 1 over 4096. The next example says that every 80 million years, 2 exponent negative 1. Remember, 2 exponent negative 1 is the same as 1 over 2 exponent 1, which is 1 over 2. So 2 exponent negative 1, or half of the mass of a sample of plutonium-244 decays to a different element. If the original mass of a sample of plutonium was 16 grams, determine the mass of remaining after 80 million years. So I start with 16 grams. After 80 million years, I want to know how much is left. Remember, every 80 million, half of the mass is converted to some other element. So this means after 80 millions, I'm going to end up with 16 times 1 over 2, which is 8 grams. The next part of the question says, after 240 million years, how much of the mass is left? So again, we start with 16 grams. After 80 million, half of it gone. So it's 16 times 1 over 2. Another 80 million, another half is gone. So it's 16 times 1 over 2 times 1 over 2. Another 80 million is going to be 16 times 1 over 2 times 1 over 2 times 1 over 2. And if you add all these 80s, you get 80 plus 80 plus 80 is 240, which is the same here. So the mass which is left is 16 times 1 over 2 exponent 3. Remember, there are 3 2's here in the denominator, so it's going to be 2 exponent 3. Now 2 exponent 3 is 8, so it's going to be 16 divided by 8, which is going to be 2 grams. So after 240 million years, only 2 grams of plutonium is going to be left.